So today I've lumped together 3.3 and 3.4. They're both really small. Um, how do we know if two triangles are similar? So if I drew two triangles that appear to be the same shape, how do we know they're similar? Yeah, so what information do they need to tell us in order? Well, these don't, I guess these kind of have a right angle in them. So if it didn't say they're similar, how could we guarantee that they are similar? What information would we need to know? Well, the only things out there would be angles and side lengths. So what could I know about the side lengths to guarantee that they're similar? If they were exactly the same, we would call that congruent. Do similar triangles have to be the same size? No, they just have to be the same shape. So if this was 5, 6, and 8, and the other triangle is bigger, let's make it a little bit, wow, that was cool. Go back. Oh boy. That did not work as expected. Okay. If this was 11, 12, and 16. So 16 is twice as big as 8, and 6 is twice as big as 12. So are they similar? No. Why not? The third one does not match up that way. So all three of the sides have to be proportional. So if you're given the side lengths and you want to know, are these triangles similar, you have to test all three sides, not just two of them. Okay. So what if these side lengths were 7.5, 9, and 12? Well, if I pulled up my calculator and I did 7.5, 7.5 divided by 5 is 1.5. 9 divided by 6 is 1.5. And 12 divided by 8, I get 1.5. Are those triangles similar? Yeah. So you have to test all three sides. What if we divided it in the other direction? 5 divided by 7.5, I get 2/3. 6 divided by 9, I get 2/3. And 8 divided by 12, I get 2/3. So it doesn't matter which direction you divide them in as long as you stick with that for all three divisions. So you don't want to do 6 divided by 9 and then do 12 divided by 8. Does that make sense? Okay. Well, what if I don't know any of the side lengths? Is it possible to determine that two triangles are similar without knowing any of the sides? The angles. What do we know about the angles of similar triangles? Yes, they are the exact same. So this angle would match this angle, this one would match that one, and this one would match that one. Do you actually need to know all three? Why two? Okay, good. They have to add up to 180. You're right. Well, let's. Good. So let's say this angle was 100, and this angle was 100, and this angle was 50, and this angle was 50. Is that enough information to determine that the two triangles are similar? Yes, because each triangle has to add up to 180, so the remaining angle on the small one would be, oh, not 40, how about 30? And then this would have to be 30. So To determine if two triangles are similar, we need all three sides to be proportional. If we want to decide that a triangle is similar using the angles, all we need is two congruent angles, two sets of congruent angles, and that guarantees that they're similar. So for this triangle, for this set of triangles, are they similar? So we have a right angle in each. Are any of the other angles equal? The vertical angles are equal. So this one matches that one. So really the only tricky thing here is figuring out which side goes with which side. Okay. So we have three angles. We have a right angle, we have a red angle, and then we have a purple angle. Okay. So this side is between purple and right. So this side matches that. And then this side is between red and purple, and this side is between red and purple. So these correspond and these correspond. Okay? So I know that 4 divided by 5 is equal to what? 4 divided by 5 is equal to which ratio? Is it x divided by 6 or 6 divided by x? So if we go from this direction, then we have to go from this direction. So 6 divided by x. Okay? No, we need to figure out how big x is. How do we solve this? If you have a fraction equals a fraction, we do what we call cross multiply. So 5 times 6 is 30 is equal to 4 times x. And then we divide by 4, and I get 7.5. Okay. The other way you could do this is say 5 divided by 4 is 1.25. So 6 times 1.25 must be x. But the problems do get a little bit more complicated than that, so setting up a proportion and then cross multiplying is probably a better idea. So let's do another one of these. So these two angles match. Which side does 2 match up with? So 2 is between the right angle and the red angle, so it matches up with x, which is between the right angle and the red angle. So 2 divided by x is equivalent to 3 divided by 7.5. Now we cross multiply. 3x is equal to 15. Divide by 3. X is equal to 5. Do you want to see another one of those? One more? Oops. All right. So x matches up with 2.5. So x over 2.5 is equal to 4 over 5. So we cross multiply. 5x is equal to, that's going to be 8, 10. divide by 2, or sorry, divide by 5, x is 2. Okay? All right. So we have maybe a street light. A street light is 2.5 meters tall, and it casts a shadow that is 1.05 meters long. At the same time, a nearby building casts a shadow that is 40.75 meters long. How tall is the building? So we have the sun shining, and that gives us two similar triangles. How do we know they're similar? Well, these are both right angles, unless somebody installed them incorrectly. And this angle is going to match that angle because it comes from the same sun. So we have two similar triangles. So what is the proportion? 2.5 divided by x is equal to 1.05 divided by 40.75. So we cross multiply. 1.05x is equal to whatever that is. So 2.5 times 40.75. So 101.875. Now we divide. So divided by 1.05 gives us 97.02, but it wants us to round to the nearest meter. So the building is 97 meters tall. Got it? All right. Next up. All right. So we need to use the tools to move the solid triangle exactly onto the dashed one and then answer the questions. So I'm going to do that from over here. So I'm going to rotate this, flip it, rotate it a little bit more. And then change its size. There we go. Okay. So we need to complete the congruent statement. So angle D matches up with angle L. Angle B matches up with angle M. So C matches up with K. All right. Now, this is asking for the fractions. So MK, which is 28, divided by BC, which is 16. So we have 28 divided by 16. We need to simplify that fraction. I can take a 4 out of each of those. So 7 over 4. Okay. And then KL is 63. CD is 36. 63 over 36. Wow, I'm really good at this. So I can pull out a 9, and I get 7 over 4. And then ML is 28 divided, ML is 49 divided by 28. So 49 over 28 is also going to give us 7 over 4. Now notice, all three match. So now it asks, are the triangles similar? Yes, they are. How do I know they're similar? Well, this one fit, and all of these are equal. So if you can't get it to fit, or if one of these does not equal the other two, then you would click not similar. All right. Okay. So we need to determine, are these similar or not? So how do we tell? Well, either all three sides are proportional, or we have two angles that match, or there's one other method that we haven't talked about yet. So are these two triangles similar? Do they have two sets of congruent angles? Yes. We have the right angle equals the right angle. We have the vertical angle equals the vertical angle. So yes, these are similar. Now it wants us to make the similarity statement. So it's saying triangle XYZ is congruent to, oh, we need to write it out. So which angle matches up with X? That would be M. So M, and then, so X, Y, Z, which angle matches up with Y? So Y matches up with N. And then Z matches up with Z. So this statement is written in a very specific order. X lines up with M, Y lines up with N, Z lines up with Z. And then what rule are we using? Well, there are only three rules. Either two angles match, three sides are proportional, or there's another one, the side angle side similarity. So this would be angle angle. Okay. Now we check this one. 18 divided by 9 is 2. 14 divided by 7 is 2. 10 divided by 5 is 2. They were all equal to 2, so the answer is yes. Okay. Which angle lines up with A? So A is between the long side and the middle side. So we go to this triangle and we find the long side and the middle side. So A lines up with F. B is between the short side and the middle side. So that would line up with D. Oops. And C is between the long side and the short side. So long side and short side would be E. Okay? And because all three sides are proportional, it would be side, side, side. All right, the last one is called side angle side similarity. So side angle side. So you have to check two things. First, is the angle between the two sides? So it's side angle side, which means the angle is sandwiched between the two sides. So here we have the angle between the two sides and the angle between the two sides. And then we have to check, are those sides proportional? So is the long one divided by the long one equal to the short one divided by the short one? So 20 divided by 16, is that equal to 15 divided by 12? Well, what do those share? A 4? Pull out a 4. I get 5 over 4. What do these share? What goes into 15 and into 12? 3. So we pull out a 3, and I get 5 over 4. So when you're dealing with side angle side, the angle has to be between the two sides, and the two sides have to be proportional. So yes, this one works. It's similar. Which angle lines up with S? Is it P or is it R? So 15 is the short side, 12 is the short side, so S corresponds with R. Okay. T is the known angle, so that's Q, and then U touches the long side, so that would be P, and then we would say side angle side. Okay, that's it for today. Get to work.